I left you with these 3 problems at the end of the last video. Just going to work through them quickly. I like to give this a name, and that way I can rearrange things in exponential form. So my base here is 4. The log is x, so the exponent is x. The argument, that's my result. This says the exponent I need when 4 is the base to get 64. And so then I say 4 to what power would give me 64? And that's 4 cubed. So the exponent would be 3. Okay. For this one, again, I like to give it a name. And then I'll just say we've got a base, an exponent, and a result. I'm making this a big triangle because I can see my result is 100 million. Now when it's log, that means common log, so the base is 10. The exponent I need when 10 is my base to get 100 million, oh my goodness, is x. So what is that? Well, nifty thing about positive integer powers of 10 is that the power matches the number of zeros. So that's 3, 6, 7, 8. Very cool. And if you're not positive if that's the rule, just remind yourself with a couple of quick examples. 10 to the first is 10. First power, 1 0. 10 squared is 100. Second power, 2 zeros. And just remember to be careful with the negative powers. 10 to the negative 1 would be 1/10. When I write that as a decimal, it's 0.1. So it's 1 digit to the right of the decimal, but now I'm counting digits, not zeros. Okay, excellent. Let's try this last one. I'll give it a name. So we're going to have a base, an exponent, and a result. It's the natural log, so that tells me that the base is e. The exponent I need when e is my base to get an eth as my result, and we called that x. Well, that's the reciprocal of e, so the power that has me take the reciprocal would be -1. Excellent. Now, in these problems, we started with just a log function evaluated somewhere. We didn't start with an equation. I created an equation by saying, I'm going to give that a name. I'm going to call that x, because then I can rearrange the equation. The homework's going to sometimes actually just give you an equation and ask you to write it the other way. So, for example, I know that 5 squared is 25. That's an exponential equation. I could rewrite that in logarithmic form. Okay. I would be saying the exponent I need, log means exponent, when 5 is my base, to get, I'm getting 25, is 2. So I'm just rearranging the 5, the 2, and the 25 like so. Okay. You could be given a log expression. So you could be given something like the natural log of e to the 4th is 4. Then you'd be asked to rewrite that in exponential form. Well, there I like to do my thing with the shapes. So I would have a base, an exponent, and a result. Here I sort of recite the sentence. The exponent I need when this is my base to get this is this. Here I like to use the shapes. Okay, so if it's the natural log, e is my base. Okay. The exponent I need when e is the base to get e to the 4th. That whole thing is my result. And this is saying, oh, that exponent is 4. That equation amounts to e to the 4th equals e to the 4th. Kind of cool. Okay. I'm going to give you two problems to try. So I'm going to give you something in exponential form. Let's say a to the b is equal to 7. Okay. So you've got 2 letters and a number. I want you to rewrite that in logarithmic form. And then let's say we had the log base m of n is equal to 2. So again, I'm giving you 2 letters and 1 number. I want you to rewrite that in exponential form. So go ahead and pause the video, give those 2 a shot. Okay, so this one here was given to me in exponential form, so I want to rewrite it in log form. So we say log, that means exponent. So this is the exponent I need The subscript is going to tell me what the base is. Looks like the base is a. To get, the argument of the log is the thing that I get, which is 7, and the log is the exponent. Well, the exponent was b. So this would be the log base a of 7 is b. Now here, we were given it in log form. We want to write it in exponential form. I like to just have shapes as my placeholders. This says the exponent I need when m is the base. To get n, that's the thing I get. That's on the other side of the equal sign. The log is 2, so the exponent is 2. So that would be a fancy way of saying m squared is equal to n.